So here we're going to do this word problem. How fast is the Earth moving through space? So we have a couple assumptions that we're going to make. The first is we're going to assume that the Earth is on a circular orbit. It's maybe slightly elliptical, but we're going to assume it's perfectly circular. And the second thing that we're going to do is we're going to assume that the distance is about 93 million miles. So that might not be exact, but it's going to be pretty close. So we're 93 million miles from the Earth. I'm going to call that the radius of my circle. And the question is, how fast is the Earth moving in miles per hour? That's going to be my goal. So the first thing I need to determine is, what is my angular velocity? Miles per hour is going to be a linear velocity. So in order to find linear velocity, I have to start first with angular velocity. So angular velocity is theta divided by time. So it's the amount of the circle. It's either the, we do it in radians divided by time. So I'm trying to determine how many radians per hour the Earth moves around the circle. So if there are 365 days in a year, and a circle is 2 pi radians, then the number of radians that I move per day is going to be 2 pi divided by 365. This will give me radians per day. But I'm seeking miles per hour, so I want to have radians per hour instead. So I'm actually going to alter this. I'm going to say, instead of radians per day, I'm going to convert to another unit. So 1 day is equal to 24 hours. So I can cancel out my day units, and I end up with, once I simplify, pi over 4,380. That's going to be radians per hour. Now I have, this is my angular velocity. And once I have angular velocity, I can find my linear velocity, because linear velocity, v, is equal to the radius of your circle times the angular velocity. So here we're very, very close to the end of the problem. I know what my radius is. My radius is 93 million miles. And I know my angular velocity, it's pi over 4,380. That's radians per hour. Now, I want to make a little bit of a unit note here. Radians, this is actually a unitless measure. It is a portion, it describes a portion of a circle, but it is unitless. So I can eliminate it from my problem at this point, and because I don't want to get mile radian per hour, like that's not a unit that makes sense. Radians represents a segment of a circle, and so it is a unitless measure, unlike degrees, which are not unitless. They're in degrees. So here I can kind of eliminate that radians, and then I can multiply out. So I will multiply this out using my calculator to get an approximation, and it will be 66,705 miles per hour. So that is pretty quick. And that is the speed at which the Earth is moving through space as it circles the sun.